Hi guys, welcome to the next section introducing the ML package. Now, we move on to the first video of this section that deals with predicting the chances of infant survival with ML. We will use the portion of the dataset from the previous section to present the ideas of PySpark ML. If you have not yet downloaded the data from the last section, it can be done using this link. In this video, we will once again attempt to predict the chances of the survival of an infant. First, we load the data with the help of this code snippet. We will specify the schema of the data frame. Our severely limited dataset now only has 17 columns. Before we can use the dataset to estimate a model, we need to do some transformations. Since statistical models can only operate on numeric data, we will have to encode the birthplace variable. Before we do any of this, since we will use a number of different feature transformation, let's import them all. To encode the birthplace column, we will use the one-hot encoder method. However, the method cannot accept string-type columns. It can only deal with numeric types, so first we will cast the column to an integer type using this block of code. Having done this, we can now create our first transformer using these lines of code. Now, let's create a single column with all the features collated together using these lines of code. We will use the vector assembler method. The input cols parameter passed to the vector assembler object is a list of all the columns to be combined together to form the output col that is the features. Note that we use the output of the encoder object, so we do not have to remember to change this parameter's value should we change the name of the output column in the encoder object at any point. It is now time to create our first estimator. In this example, we will use the logistic regression model. We will load the whole section here. Once loaded, let's create the model by using these lines of code. We would not have to specify the label col parameter if our target column had the name label. Also, if the output of our features creator was not called features, we would have to specify the features col by calling getOutputCol method on the features creator object. All that is left now is to create a pipeline and fit the model. First, let's load the pipeline from the ML package. Creating a pipeline is really easy. Here's how our pipeline should look like conceptually. Converting this structure into a pipeline is a walk in the park. That's it. Our pipeline is now created so we can estimate the model. Before we fit the model, we need to split our dataset into training and testing datasets. Conveniently, the data frame API has the random split method. The first parameter is a list of dataset proportions that should end up in, respectively, births train and births test subsets. The seed parameter provides a seed to the randomizer. Now, it's about time to finally run our pipeline and estimate our model. The fit method of the pipeline object takes our training dataset as an input. Under the hood, the births train dataset is passed first to the encoder object. The data frame that is created at the encoder stage then gets passed to the features creator that creates the features column. Finally, the output from this stage is passed to the logistic object that estimates the final model. The fit method returns the pipeline model object that can then be used for prediction. We attain this by calling the transform method and passing the testing dataset created earlier. Here is the command that shows how the test model looks like. It will generate this output. As you can see, we get all the columns from the transformers and estimators. The logistic regression model outputs several columns. The raw prediction is the value of the linear combination of features and the beta coefficients. Finally, the prediction is our final class assignment. Obviously, we would like to now test how well our model did. PySpark exposes a number of evaluation methods for classification and regression in the evaluation section of the package. We will use the binary classification evaluator to test how well our model performed. The raw prediction col can either be the raw prediction column produced by the estimator or the probability. Let's see how well our model performed. This result will be produced. The area under the ROC of 74% and area under PR of 71% shows a well-defined model, but nothing out of the extraordinary. If we had other features, we could drive this up, but this is not the purpose of this section. PySpark allows you to save the pipeline definition for later use. It not only saves the pipeline structure, but also all the definitions of all the transformers and estimators. So you can load it up later and use it straight away to fit and predict. It will produce this result. If you, however, want to save the estimated model, you can also do that. Instead of saving the pipeline, you need to save the pipeline model. To save your model, we will define this example. This code uses the load method, a class method of the pipeline model class, to reload the estimated model.